Hello, everyone, and welcome to Calculus. This is a Shaffer snapshot on differentials. So, given dy dx, this is what you're used to seeing, this is the derivative, the differential dx, so that means just the dx portion of that is independent from the differential dy. In other words, you can separate it into pieces. So we have three steps that I'm going to use. You can screenshot this if you want to, but I'm going to jump into my example. The radius of a circle is to be increased from a radius of 10 inches to a radius of 10.1 inches. We're going to use differentials to estimate the change in area. It doesn't actually calculate it exactly, but it does give you a really good estimate. So step one, do the derivative the way you normally would. Area is pi r squared. dA dr is equal to 2 pi r. Step two is to multiply both sides by the differential in the denominator. This clears the fraction and isolates the differential that we want, which is dA. So just so you understand what it is that you're doing, dA, d, we know is derivative, but think of it also as delta, which means change. So in other words, the change in area is equal to 2 times pi times the radius times, again, the delta or change in r. Now we're going to apply that differential to a very specific example. The change in area in this problem, if you change the radius from 10 to 10.1, so your radius was 10, and your change, your delta r, your change in radius, is 0.1. Since 1/10 times 10 just cancels, you get 2 pi, which isn't completely informative because maybe you can't picture that number in your head, but if you multiplied it out, it's 6.283. We do have to add a unit since this is in inches. We are in square inches for the area. So if you change the radius by 1/10 of an inch, you'll be changing the area by 6.283 square inches. And that's differentials. If you would like to see more examples or worked out practice problems, there is a full-length video, and that link is in the description for you. Have a great day.